In this example, we're going to be adding two rational expressions, and specifically, the denominators are going to be different from one another. So, to add rational expressions, we always have to have the same denominator. It's just like when we're adding fractions together, we can only add thirds to thirds. We can't add thirds to fourths. We need to have the same denominator between each part of this expression. So what I need to do is look at each of the denominators here. So there's an x plus 3 and there's an x plus 3 squared. And I need to come up with a least common denominator for these denominators. So conveniently, this is an x plus 3, and then the second fraction is just a squared version of the first fraction. So if I looked at the first denominator, x plus 3, and I looked at the second denominator, x plus 3 times x plus 3, because that's what squared means. If I kind of match them, this one only goes yay far, and this one goes yay far. I need to go the furthest with each of these factors. So the least common denominator is going to be x plus 3 squared. I need to take the most of every unique factor, and that is my least common denominator. So the most of this factor, x plus 3's are the same, but this one has 2, this one has 1, so I'll take 2, which makes x plus 3 squared. So now I need to rewrite my fractions so that there is an x plus 3 squared for each fraction. Now the second fraction is fine because the least common denominator is its denominator, so nothing changes there. We'll just keep the 4. The first fraction though, how did I get from x plus 3 to x plus 3 squared? Well, what would I multiply? I'd need to multiply by an extra x plus 3. So if I saw over here on the side x plus 3 is multiplied, I also have to be fair to the numerator and multiply it by x plus 3. That's how I get the x plus 3 squared to the denominator. So I need to multiply the numerator by that value too. So I'll have 7 times x plus 3. All right, so I found the least common denominator and decided what it needed to be. The second fraction needed no changes. The first fraction needed to have an x plus 3 multiplied to the numerator and denominator. And now I have two fractions with similar denominators. At this point, I can now combine all of my terms into one fraction. X plus 3 squared is the denominator. And because we have addition, we can just write all of our terms all in a row onto our numerator. 7 times the quantity x plus 3, and then add 4. So we're almost done, but this isn't simplified enough. So I need to get rid of the parentheses on the numerator and try to combine all like terms that I can. So I'm going to do a little bit of distributing. So 7 times x is 7x, 7 times 3, so that's a 21, and then I am adding 4, and then the denominator hasn't changed. Here's x plus 3 quantity squared. Okay, so go to our numerator. What can we combine? Looks like 21 and 4 are like terms. 7x, there's nothing like it, so we'll keep 7x by itself. We'll add 25, and then our denominator stays the same, x plus 3 squared. So at this point, we would check, do you think we can factor the numerator? Well, 7 does not go into 25, so there's no greatest common factor there. And there's definitely not an x plus 3 in any of this, so we're actually done now. we have simplified, and there's nothing else that we can simplify any further, so we'll have our answer of 7x plus 25 divided by the quantity x plus 3 squared. So with our addition with these rational expressions, we first looked at the denominator, decided it was different and we needed a least common denominator, created that least common denominator, added the numerators, simplified what we could, factored if we could, and we couldn't, and then we got to our final answer.